Hello, everybody. We're going to go ahead and get started. This is the InduSoft webinar covering IoT implementation with InduSoft Web Studio and the TagWell Driver from SoftPLC. If you're not familiar with what IoT is, it's Internet of Things. A lot of people are using slightly different terminology for that, and we're going to talk a little bit about that as we get going. A quick introduction. My name is Scott Courtier. I'm with InduSoft. I'm Senior Technical Sales. And briefly, I'm going to give you an IoT overview as I see the Internet of Things, and then talk a little bit about drivers. And then we're going to hand this over to Cindy, our very special guest today from SoftPLC. And she will go ahead and present on how this was implemented and working with the TagWell Driver. So. Again, for those of you who are just joining us, I can't hear you. We can't hear you on this presentation. So if you've got comments or questions, put those into the chat panel or the Q&A panel as we get going here, and we'll get to those questions as soon as we can. Also, we will be recording this, and we'll publish this in just a couple of days. There'll be a follow-up survey, and if you give us your name, address, and shirt size, we'll send you a free T-shirt. So thank you for joining. All right. So I wanted to talk about this Internet of Things concept. This is a relatively new term that has been thrown around for, let's say, the last few years, last couple of years. And I've been trying to personally grasp the idea of what is this concept? What does this mean? Now, Cindy might have her own take on it, and other people might have their own take on it. And when I tried to understand this, or where I thought I started to understand it, is the Internet of Things is this idea of where you might have a small computer, small device, could be the size of a thumb drive, could be a board, a computer board hidden inside of a piece of equipment that's the size of a deck of cards. Who knows what size it is, but it's this thing that's out there that's either collecting data or reading sensors or controlling some local I/O. And then sending information, raw data, up to a database or up to the cloud to then be analyzed and then provide you with some insight. Now, the idea here is to take the raw data, the bits and bytes, and by doing some analytical type analysis on that, it really turns that raw data into meaningful information, something that you can act on, something that you can react to. It's a feedback mechanism. If any of you have ever done any motion control, you're going to understand the idea that getting feedback from your motion helps you determine where you're at and where you're going and how fast to get there. And this is a similar idea, and this Internet of Things concept can mean a lot of different things to a lot of different people. It could be in the commercial space. It could be in your home. It could be in industrial automation, on a smart pump. It could be in a vending machine in the local shopping mall. You name it, lots of different things where you might need to collect data and get that information back and understand what's happening and why it's happening. And so the idea might be that these things, these endpoint devices, are typically going to often be some type of embedded operating system, whether that's a Windows CE, a Linux, a VxWorks, the list goes on and on and on. And they're very often small footprint. And what do I mean by that? Not only physically small, but a small amount of memory, a small amount of low horsepower CPU, low amount of resources in general. And often there's going to be no display on these. These might be out embedded in some type of equipment where you don't have a physical display to be able to see anything, and that's why you're going to need this remote connection to be able to get to this or do your analytics either online or through the cloud. Now, some concepts that helped me kind of like grasp this idea, I'm going to show you on the next slide. But as you understand this, and there's possibly in the prediction that I've seen in studies says that there's going to be multiple billions of these things deployed over the next 5 to 10 years, and depending on what survey you look at, that could be different numbers. So, as you're collecting all of this information, are you collecting information just to collect it? Don't collect data just because you can. Collect it because it means something to your common term is a key performance indicator, a KPI. It means something to your process, and don't be afraid to adjust what data you're collecting. But again, you might have, if your product does well, hundreds or thousands or even possibly millions of these devices out there collecting data, and it could be overwhelming. And so I found a cartoon online that I thought was pretty relevant, and this says basically, don't collect data just to collect data. So it says, let's solve this problem by using the big data, which is the concept of having all of these many, many devices collecting data. By using data, none of us have the slightest idea what to do with. So again, don't collect data just to collect data. So again, the few examples that I have in the commercial environment is the Nest thermostat. And this, if you're not familiar with it, it's a thermostat that replaces your wall thermostat in your home. And it's got this nice heavily weighted dial on here, and you rotate this. And what it does is it connects up to your home router and sends the information up to the Nest cloud services. And it can track things like the weather outside and adjust the temperature inside based on higher or lower temperatures outside of your house. So that feedback mechanism is important. This swing bite thing, this is something for golf enthusiasts, and if any of you know me, I'm very much into golf, and I have one of these that plugs, just wraps around the handle of or the grip on my shaft of my golf club, and it connects Bluetooth to my phone or tablet. And when I go to the driving range, I swing this thing, it sends the information to my phone, and then it forwards it up to the SwingBite cloud. And then right away I can get instantaneous feedback on how I'm hitting the golf ball. I can even get right on my phone or tablet a 3D rotatable view on how I swung the golf club and make instant adjustments right there. I don't have to have somebody watching me. And again, it's that feedback mechanism that's all important to be able to change, to be able to improve. And the third thing is, maybe you've seen this, your printer now can tell you the status of the ink levels and possibly even order ink for itself online if you give it permission to. So really kind of neat thing. So these three things were something that helped me grasp the concept of Internet of Things. You have something embedded in a device that has a small little display, something that doesn't even have a display on it, and then the printer often will have a display on it, but will also pop up notifications onto your computer screen. So again, these are commercial. I understand these are commercial examples, but these help me grasp the concept. So what does InduSoft have? Well, if you look at how long we've been doing this, back since the late 90s, we've had our product called CEview, which ran on an embedded operating system from Microsoft, Windows CE. So we have CEview and Embedded View, and those are current products that we have now. And just to let you know, our upcoming version, which will be later this summer, version 8, is going to have some very special features in it just for Internet of Things type applications. So I wanted to talk a little bit about, since a little bit of Cindy's presentation is related to drivers, I wanted to talk about drivers just real quick, just a couple of minutes here before I hand it over to her. The InduSoft Web Studio product has over 240 built-in drivers, and there's no additional charge for these. Some of our competitors force you to use OPC as the driver mechanism. Well, for us, it's not needed. It's optional to use OPC. We are still very active in the OPC Foundation. We still participate in their workshops, and I've done technical presentations all around the world with the OPC Foundation. So we're a very active participant in their organization. But using our built-in drivers is typically more efficient because our product then talks right to the device as opposed to having to go through essentially a translator. One of the things that I can recommend is that you check the online list for updates. Let me grab our website. So whenever you start a new project in InduSoft Web Studio, it's probably a good idea to go check to see what driver version is out there. So if you decide that you want to go to our website and take a look, and you have a way to filter here, but what I'm going to do is say show me all, and then I'm going to scroll down to the SoftPLC, and these I believe are in alphabetical order. Go down here is SoftPLC. So here's the TagWell driver, and if you do a click on that magnifying glass, it'll show you that the current version is the 1.0.0. So if I move the web page out of the way and I open up InduSoft Web Studio, you can see here that we've got the TagWell driver installed. I pre-installed that before we started. But if I was to take a look at this in my project, when I went to drivers, I right-clicked and said add remove drivers, and this will show you the list here. I've chosen the TagWell driver, and here you can see that that is version 1.0.0. So you know it's the latest because it matches the website. And so that's a good place to go look if you're going to start a new project, or at least understand what the differences are before you start. So there's that. And I want to talk briefly about the main versus standard worksheets. When you first install a driver, you get this main driver sheet, and basically you can put any tag type into here, and it communicates roughly at 600 millisecond update rate, but you can mix and match and really put anything that you want to in here. But some people want a little bit more control than that 600 milliseconds. So what they'll do is they will insert another driver sheet, and this is, let me split screen this a little bit here. You can see, if I put these things side by side, that the main driver sheet really has these 4 different statuses. And while the standard driver sheet, this new one that I just added, in addition to the 4 statuses, now has these triggering fields with the ability to trigger as fast or as slow as you want to. And Cindy's going to talk a little bit about why you might want to trigger that a little bit slower than as fast as you can. So I'll let her talk briefly about that. Let me get back to the PowerPoint here. And I'm not going to go into all these details, but here's a nice little chart on what's different between those 2 different sheets. And talked about that and give you some examples. The standard driver sheet here. Something else that I wanted to point out before I hand it over to Cindy is to take a look at the driver manual. Now, what you can do here in the development system is go to Help, click on Communications Drivers. Now, the Communications Driver manuals are not part of the main technical reference within Web Studio. So you have to click on this and then scroll down to, in this case, the TagWell driver, which I'll find that there, and click on Help. Now, this will open up the PDF of that, and one of the things I want to show you is that most of our driver manuals are laid out in the same order, where it talks about configuring the driver, setting up the worksheets like I just showed you, and then talking about troubleshooting. Well, I wanted to briefly go down to the section where we talk about configuring it and point out something that I noticed. This is a little bit unique about this driver. It's a little different, a little unique compared to other drivers, is that if you take a look at this note, tag names are case sensitive. Tag names with the wrong spelling or wrong case will give you an error. Now, what that refers to is not the InduSoft tag. So, for example, here in this driver worksheet, I have the InduSoft tag or the Web Studio tag that is temperature. That one is not case sensitive. The one that is case sensitive is this tag name for the controller itself. So just be aware of that. Something I wanted to highlight if you're going to use this. And I think that is it. Cindy, I'm going to go ahead and take you off of mute. Can you hear me?
Thank you all for coming today. I'm going to start a little bit briefly to talk about who SoftPLC Corporation is in case you don't know of us or what we do. We actually were founded back in 1983 as Teledenken Resources. We did some PLC-type support software and drivers. And back in 1993, I believe, we changed the name of the company to SoftPLC Corporation because that is our core technology. And so we felt it more appropriate to be known as SoftPLC. We are focused on industrial automation products. Our expertise has always been in embedded and communications type software, operating systems, real low-level type products. And so you'll find that in all of our products, the communications are really optimized for not only performance, but also to make sure that error reporting and all that is taken care of very nicely. We've kind of got a reputation as being innovators. We have a lot of industry first type kudos to our name. What we tend to do is take open architecture and computer-based technologies and apply them to industrial automation products. The computer industry tends to move very fast and be very innovative, whereas the industrial automation market is a little bit slower. So we try to move that computer technology into the industrial automation market so that we can take advantage of those things. We're also an extremely customer-driven company. It's not unusual for a customer to request a feature, and we'll drop everything that we were planning to do on our own and add that feature into our product for them, and then that becomes part of our standard product. We can react quickly. We have a lot of hooks in our products. We have a lot of interfaces, open architecture interfaces that allow us and our customers to do things like customize it for a particular application or adapt it for talking to something else or tweaking it. And so because of the way our products are architected, we can very quickly meet customer needs without a big, long development cycle or a lot of cost. So if I just briefly go over our core products, our main technology is SoftPLC, which is a programmable automation controller line. And the way our packs are designed is we have an embedded Linux kernel with a runtime software that we embed into different hardware platforms, and those become the same type firmware programmable controller with different hardware. So we have things like this little guy here, which we call our micro. It'll fit in the palm of your hand. Has Ethernet and serial type communications, but not a whole lot of other ports. This is our smart SoftPLC line. As you can see, it has an embedded Ethernet router. It's got 6 serial ports. It's got expansion for adding things like field buses like Profibus, DeviceNet, CAN, and other type interfaces. And then we have what we call our hard books, which are industrial computers that we put the software on for very, very high-end applications where we need dual-core processors, quad-core processors, extremely rugged temperatures, or a whole lot of expansion slots or that sort of thing. So we have, like I said, a range of hardware models, but the firmware, the programming software, and all the features are the same. The packs can also be considered as gateways or protocol converters. Because we have all these drivers and all these ports, just by not necessarily changing the product, but changing the way you think of it, it slides in very nicely as a gateway between differing networks. TagWell, which is our focus today, is our cloud-based remote management platform, and we're going to talk about that in more detail, so I'm just going to mention that now. And the last thing I want to mention is that we have partnered with InduSoft for many, many years, since InduSoft started, actually. And we actually have an OEM version of Web Studio that we sell as SoftPLC Web Studio, and we package it with industrial computers so that we can offer an HMI-type product where we do the integration for the customer so they don't have to worry about having the Windows CE be compatible and that sort of thing with the CE view. So the next thing I want to do is actually get into the TagWell and the interface between Web Studio and TagWell. So first, some definitions. Scott did a great job talking about what is the Internet of Things. If you go on the Internet, you can find 8,000 definitions. But what I do want to mention is that the term M2M, or machine to machine, is used interchangeably with IoT a lot of times. M2M tends to be used more in our industry than the IoT. The IoT is very generic. It talks about refrigerators letting you know when you need to order milk, and golf clubs and other things, whereas M2M tends to be used more when we're talking about industrial systems or controllers or that sort of thing. But it's basically the same thing. It's devices talking to devices to the cloud, to each other, so that people don't need to be involved, but the data becomes available. So what is the cloud? The cloud's the Internet. It's just a fancy marketing term. It's just all the servers and thin clients and routers that are out there connecting all these computers together. Cloud computing is the applications that run in the cloud. And those can be a wide variety of things, but some common parameters of cloud computing is that it's on demand. You don't need to install anything. It's there for you. It's on the Internet. You just need to access it. It's location independent. You don't know where that server is. You don't really care. The cloud service provider takes care of making sure that the service is available regardless of conditions in terms of resources, natural disasters, that sort of thing. And resources can be allocated based on demand. You don't need to have somebody go run out and buy another drive. It's all there for you. It's all taken care of. So there's different kinds of clouds. There's private clouds, which are for use by a single organization, which could be at an office, or it could be at a third-party provider like Amazon or Microsoft or IBM. There are public clouds, which, again, could be anywhere, but they're set up for use by the general public. And then there are hybrids, which is a combination of the two. The services available, they used to talk about platform as a service, infrastructure as a service, software as a service. Those terms have all kind of gone by the wayside because there's been so much blending of what's being offered by the different applications. So instead of that, I'm just going to list the kind of things that are available. So you have infrastructure. These are the things that the IT department would typically provide. You've got hard drive space for your database. You've got networking services. You've got security. You've got backup. All of those type infrastructure computer services. You've got software applications. Cloud software applications are going to run in a thin client or a web browser. That means you don't need to install something on your computer to run these type applications. The third thing that is available is software tools or development products that allow people to develop cloud-based applications. And the idea here is, again, you don't need to purchase or install something to build an application, and it becomes available to the whole team regardless of where that team is located. And so people who provide cloud services will offer, as I mentioned, combinations of these things. And cloud services are typically fee-based subscription products. And it's based on usage, which might be number of users, might be amount of disk space, might be time, but they're typically a monthly fee or an annual fee that gets adjusted based on if the usage changes. And so again, these things are dynamic. You don't need to commit upfront to more than you think you need. If you get too much and things scale back, you can usually scale back without too much of a penalty. The next thing I want to talk about is a private subnet, and this is key because this is where you can get security for your devices. So a private subnet is a group of nodes that are networked together on a common segment with private IP addresses. So that means that they're not published on the internet. They're not available to anyone. So for example, when a corporation has multiple offices and they set up their structure, all those different computers can talk to each other, but I can't go in and talk to somebody at InduSoft's computer, for example, unless they allow me to do so. Cell phones is another example. Your cell phone is on a private subnet of the provider, and it has access to the internet, but people don't have access to hack into your cell phone. And then the third example is going to be machine-to-machine type nodes. So where you have maybe some remote lift stations in a water utility, those can all be networked together, but they can be protected by putting them on a private subnet. So subnet nodes can talk to each other, but they're protected from access by the public unless special techniques are used, and TagWell is one of those special techniques. So just real quick, the benefits of cloud computing and Internet of Things is reduced need for capital equipment. You have unlimited processing capabilities that's dynamically allocated. The cloud service provider, the platform provider, is going to have built-in redundancy and disaster recovery. Now, every cloud provider will not have that, so you need to choose carefully. You want somebody who's really in the business and has things like servers in multiple cities, so if there's a flood or a hurricane, you're not going to lose access to everything. And you want to make sure that everything's backed up, and the good providers will provide that for you. And the other benefit of cloud-based computing is faster deployment and development, because a lot of the base functionality is there. You don't have to build it from scratch. And because, again, it doesn't matter where this stuff is, everybody has access, whether they're traveling, whether they're at home, in the office. You've got built-in reliability and a lot of security because of the way you've got experts setting up these private subnets and other cloud-type infrastructure. Okay, when we talk about TagWell, TagWell is a public cloud service, and what we're providing is bidirectional access to and from protected remote nodes via the internet. So again, on a private subnet, the nodes are protected unless there's something special that provides access. And so TagWell is a service that's going to provide that access. And the other term that we use is something called a SoftPLC remote. And a SoftPLC remote is a device that can communicate to TagWell via a connection like cellular or satellite or a hardwire through something like a public subnet like the internet. So in every TagWell type implementation, you're going to have a SoftPLC remote, which is going to be a controller or a gateway or something that runs the SoftPLC firmware, which can be a very, very small embedded computer like a Raspberry Pi, for example. So a SoftPLC is, again, a low-cost pack that can be used to do control and communications, or it could be just a communications gateway to another system like an Allen Bradley PLC or a Siemens PLC or a drive or whatever else is out there. When we use the term SoftPLC remote, another way to look at that is RTU. It's any SoftPLC connected to TagWell via the internet, and that can be through a variety of modems or wireless type connections or hardwired connections. SoftPLC itself has a lot of features that, when you put it out in a remote location, can eliminate the need to have an operator interface. We've got an embedded web server that allows you to build web pages that can be used as operator interface. We've got email and text messaging, so we can send out alarms. You can send out reports. There's an embedded firewall that can be activated so that that remote node is protected, even if it's just sitting on a regular modem, or somebody drives by and connects their own computer to it. The firewall is going to prevent access if you want it. And the nice thing about not having a fixed HMI at these remote locations is, if there's nobody there, that's a lot of cost and potential maintenance of a piece of hardware that isn't used a lot. HMIs are fairly fragile. When you talk about extreme temperatures, they take up a lot of space, that sort of thing. So there's some benefits to doing it this way. So I like to call these drive-by browser interfaces. So you have a SoftPLC talking to some kind of controllers or some kind of type of system that you want information about, and you can equip it with a Wi-Fi or a Bluetooth interface, and the guy in the truck can drive by and pull up a web page, change the set point, view the data, that sort of thing. That would be a very simple implementation. Now, if I want to go to the next step and I want to get this up on the internet, that's where TagWell comes in. So TagWell is going to give me a bidirectional path. It gives me an API, which is Application Program Interface, that allows users or SoftPLC to develop applications that will run in the cloud to display or do something with the data that's being sent to TagWell. And it's a cache for, I'm using a little bit different term than Scott did. We call it interesting data in the remotes. So what that means is that as a user, you can decide what's interesting, and that's the only data that's going to be sent to TagWell. All the information isn't going to be sent there. And so you could sit, where's my mouse? There it is. You could sit here on the internet with a computer and connect to a modem and through NAT routing talk to the private subnet. And you can read the data. That's not that secure, but you could do it. But what you can't do is write to those nodes because they're on that private subnet. So what TagWell does is provide the security of accessing the data to read it, and it also provides a way for you to write the data. The other key thing when we design TagWell is that when you talk about a cellular or a satellite type connection to the internet, that can get very expensive. We talk to some customers that have thousands of remote nodes, and they need a way to talk to them, but they can't afford a $100 a month cell plan or satellite plan. So what we did is we designed the whole system to really scrunch down the amount of data that is being sent, the way the data is being sent, the way that we're checking the communications, how often things happen, so that we keep those costs down. So it's not unusual that you could have a data plan for a thing or a SoftPLC remote that is going to be less than $30, $40 a year. The other thing TagWell has is an SMTP server. What that means is that via that service, the SoftPLC remotes can send email or text messages. So in the event of an alarm, a text message could be sent by the remote to a selected list of people based on, which alarm and continuing order status and all that, or order of urgency, those type of functions. Or an email could be sent with an attachment that's a production report. So you've got that capability as well. And TagWell has a HTTP protocol level that allows applications to access the interesting data. It is password protected, which means that one customer can't get to another customer's data that's up in TagWell. It's all segmented that way. And so some of the things you can do with the TagWell data is you could develop web browser interfaces. This is one example from a customer that they do restroom controls. The city can go in and turn the lights on and off, lock the doors. If the toilet's running and overflowing, they can shut the water off, that sort of thing. They can see if there's an alarm, security alarm, fire alarm, that sort of thing. So you can build these little web interfaces. The Web Studio TagWell Driver uses this HTTP protocol. So you can run Web Studio applications on the TagWell data with that driver. And then, again, using the API, applications can be written that can do just about anything you might want to do. So, for example, you could gather the data and write it to a SQL database. You could generate custom reports, things like that. If these applications are written and you want to host them in the cloud, we do offer services to help you do that. That's an expertise that we have, and sometimes it's not that easy to do, get things up in the cloud, so we are available to help with that. I want to stress in this slide the word inexpensive. There are a lot of competitive cloud-type products that you could end up spending thousands of dollars a year to do what we're doing here. We try to keep the cost down. We're providing a cloud service and some communications ability at very low cost. And there's two ways to do that we do that. One is we minimize the amount of data, and the other is we're not greedy. But anyway, so I talked about some of the features that minimize the communications cost by the way that we do the data delivery. Another thing that I haven't mentioned is that the actual way the remote talks to TagWell is through a ladder logic instruction. And so you can have in your SoftPLC remote multiple rungs that determine when the data will be sent to TagWell and what data will be sent to TagWell. So you could have, alarms are sent upon events. You could have production information that's sent on an hourly basis or a daily basis. And then you can have other tags that are sent only if something changes, or if the SoftPLC notices something different going on based on your logic, it can say, hey, all of a sudden I'm interested in these other tags. These become interesting where they weren't before, and you can start sending those. So there's a lot of control within the remote as to what and how often that data is sent. The other thing I want to mention is that when something is written to TagWell, like you change a set point or you want to start up a new process or change the recipe you're running or whatever, TagWell will only write the tags that changed. It's not going to write all the tags. So again, that's a way that we keep the communication overhead lower. So everything I've talked about so far is just TagWell and SoftPLC working together, but now I want to talk about what happens when we add Web Studio into the picture. The Web Studio TagWell driver allows you to read and write to the remotes through TagWell. So when you're talking to TagWell, it's as if you're talking to a bunch of PLCs. So it's similar to any other Web Studio application where you're directly connected to controllers. Each remote and its tags are available through those driver worksheets. And so you have a lot of control of how often you talk to each remote and which tags you're interested in through those driver worksheets. Another thing that you can do is with the Web Studio scripting feature, you could use the TagWell API and develop application code that would allow additional functions. And at the end of the presentation, I'm going to go through an example of where that might be useful. But one example here would be a file transfer. Let's say there's a data log file in the remote that you want to access, and rather than sending all those tags up and blowing out your cell plan, you could just do an FTP type transfer. So some application benefits of using Web Studio for SCADA. When you use just a web interface through TagWell, you're pretty limited. HTML is very powerful, but it doesn't have a lot of the built-in functions that make it quick to develop a dashboard type interface. With Web Studio, you've got the library, you've got the built-in functions for trending and alarming and event logging and all that sort of thing. You've got the database interface. All those things are built into Web Studio, so you don't have to develop them from scratch like you would with just a web page type interface. So we find most customers use the TagWell web interface for operator interface functions, not for SCADA level functions. The Web Studio interface to TagWell, again, is the same as if you're talking directly to a PLC. So everything's available, everything's on the table. A lot of the competitive products provide a set of tools for you to build your interface. And what we hear is that, oh, it does almost everything I want, but I can't do this, or I don't like the way it does this, and it limits me to 100 tags, or it limits me to this particular file format or whatever. And so with Web Studio, none of those limits apply because all of the functions become available. The benefit of using TagWell with Web Studio versus having Web Studio directly talk to the remotes is, number one, the bidirectional communications to the private subnet, but also you're going to have a better throughput to the remotes than if you were going directly yourself. TagWell has optimized the communications to the remotes. The data is just sitting up there in the cloud. So Web Studio is just talking to the cloud on your regular high-speed internet connection. There's also reduced cost because the tags that are interesting are in TagWell, and Web Studio can grab them. And if the data hasn't changed in the remotes, or the remotes haven't decided that the data needed to be reposted to TagWell, Web Studio can read them as often as it wants with no cost on the cell plan, because it's just reading TagWell. It's not writing to the remotes. Now, the opposite there is if Web Studio is going to write to the remotes, that's going to cause another packet to go down, and so those driver worksheets become very important. So by using the triggers on the driver worksheets that are pertinent to tags that are being written, you can minimize how often that's going to happen. So a couple different ways that Web Studio can be configured to talk to TagWell. Here, Web Studio is talking to the internet, which is talking to TagWell. So this would be like in your office, and all the remotes, the data is going to flow this way. The problem here could be if other people need to access this Web Studio application, you have to worry about the security of that. So if you just put this Web Studio on the internet, you have to protect it from hackers or people who shouldn't be in there. Another way to do it is to actually install Web Studio in the cloud on its own private subnet. And now you've got those same protections built in. And SoftPLC can help you do that. So by running Web Studio in the cloud, you're getting security built in through the cloud structure, and you've also got the infrastructure benefits in terms of dynamic allocation of database storage and backup and all those sort of things. So let's talk about an example here. I've got a little controller or a remote that's talking to some oil wells, and it's controlling them, and it's reading the data from them, and it's doing some data logging. And let's say the guy comes by and he gets his production report, he gets his alarms, that's all nice and good. But now they want to do that remotely, so we add a cell modem, we add the TagWell interface, and now all that information's available remotely. And I can have both. I can have a wireless interface, and I can also have the cell interface. There's no reason not to be able to do that. Now let's say I've got a whole bunch of other locations. I'm the same customer, but now I've got some other locations that I want to be accessed remotely. I can have multiple PLCs or SoftPLC remotes here that are talking, let's say on Zigbee. And one of them can be equipped with a cell modem as a master so that I only have one cell plan at this location. So I can, again, minimize the cost. This guy has all the tag information from all of these, and that gets sent up to TagWell. And then I can add my Web Studio for my SCADA level type application. We actually have a customer who does this, and what they found is that there's certain information that when there's a problem, they need to do some very high-speed data logging, and the cell connection is way too slow to do that. So the SoftPLC is programmed to capture that data very quickly and create a log file in a CSV format. And then up here, there's an application that can say, all right, if this event happened, there's a log file I need to read. I can go get it through FTP and bring it up here, put it in my database, and now I've got much finer level details in the Web Studio application than I would have had just from my standard polling it every 15 minutes or whatever. So there's a lot of flexibility here. And again, it's all designed to allow you to spend as little or as much money as you want in terms of the cell plans by optimizing how the communications is sent up to the cloud. So in summary, SoftPLC's remotes, TagWell, and Web Studio together make the Internet of Things possible, the M2M applications, very low cost, especially when compared to some of the other solutions out there, and nearly effortless because you're using standard technologies that you would if you weren't doing the cloud remote configurations. The remotes are very low cost, very flexible in terms of the type of communications, the amount of capabilities, the amount of protocols, all that sort of thing. And the communications are extremely optimized. So whether you have a remote that has one data point or you have a control system that has thousands of data points, these products can handle that application for you. And contact information, thank you for your time. I'm going to turn it back over to Scott.
All right, Cindy, thank you very much. Can you hear me?
Yes.
I'm going to just do a couple of things that I happen to notice while Cindy was presenting that might be of interest to you. Let me go ahead and get a couple of things going here in the background. All right, so if you have any questions, put those in the chat panel or the Q&A panel. So while Cindy was presenting, I remembered that we actually have done a webinar on cybersecurity. We did this, looks like this was posted back in January of this year, and I don't remember this specific one because I didn't host it, but I think maybe Richard did. And it looks like we had a guest speaker maybe even, and the slides are up there, the video is up there, and looks like we had Stephen Miller. Maybe I was part of this, I don't remember, but the thing that I wanted to point out is we've got these e-books that we did on cybersecurity and control system security. So you might want to take a look at those if security is an issue for you. And another thing that Cindy pointed out was, you know, a lot of times in industrial automation, we're always, especially in machines, we're trying to speed up the way that a driver works or increase its speed. The driver sheets, the main driver sheet here normally connects to a controller at 600 milliseconds. But if you add these standard driver sheets, and let's insert one here, then I can put, let's say, for example, a trigger on how frequently I want to write this. And this could be a tag name. Let me just put in here a tag called trigger. We'll call it trigger 1. And I don't have that trigger created yet. Maybe I'll make that a Boolean. And then I'll go back into my tasks here, and under scheduler, I can do a couple of different things. Let me insert a new schedule worksheet here, and I can put that, set this up for calendar, which means it's going to use the time in the date field, or optionally the date field. And when it does this time field, this is going to be the time of day. So if I want something to happen at 2 a.m., I would put 020000 for 2 a.m. with hours, minutes, and seconds here, and then leave the date field blank, and then I would take that trigger and then just invert it, or say not trigger 1. So every morning at 2 a.m., you could cause it to maybe burst that communications and have that happen. And if it's over an expensive leased line, whether it's satellite, a radio modem, or something that's expensive, you can maybe set that up this way. Alternatively, instead of calendar, if you set this to clock, then the time field becomes a frequency or a period. So maybe you want something to happen not at 600 milliseconds, but you want it to happen every 15 minutes, let's say. Then you would do hours, minutes, seconds, and then it would trigger this tag every 15 minutes, let's say. And you could adjust that and then disable it, let's say, on the weekends or whenever a certain condition is present. So hopefully that answers some of those ideas on how you would do that. And we have a question: can InduSoft Web Studio be connected to a PLC via Modbus TCP using RTU? Yeah, that's one of the included drivers that we have. Let me just show you real quick on how to do that. So we go into communications, we'd add another driver. Depending on your license, on average, let's say a 1500 tag license allows you to have 3 simultaneous drivers. So what I'm going to do is scroll down here to the Modbus TCP, which is Modbus via the RTU via TCP, add that, and so that's how you would do that. So hopefully that answers that question for you. If there's any other questions, please feel free to put those into the chat panel or the Q&A panel, and Cindy or I will try to answer those. Let's see if there's anything else that I have in my part of the presentation. So we're in the Q&A section here. Thank you for those questions that have come in. And Cindy, again, I'm going to thank you. We really appreciate you taking the time out of your busy day, and I'd like to thank everybody who's attended today for taking the time to join us. We've been doing this for a few years, and we've got a lot of these webinars built up on our website. So if you have some questions or want to see a particular type of topic covered, if it's not on there, let us know when we send you the survey. Fill that out. We'd love to create some topics that are helpful for you in the future. So I got some good compliments coming back. Thank you. And Cindy, do you have anything else to add?
Nope.
All right. Well, with that, I'm going to go ahead and end the webinar. We've got some more compliments coming in. Thanks, everybody. And everybody have a great rest of the day. And thank you very much for attending, and we'll see you in the next one. Have a great day.